Hello students, welcome back to JCE Connect series of lectures. So in previous lecture we have started module number 4, that is impact of jet on a curved wings, and we have discussed about impact of jet, that is what you mean by impact of jet, and uh, how this force can be analyzed, that is impact of jet force can be analyzed. So we have discussed about the impact of jet in previous lecture. In this particular lecture I'll be discussing about some fundamental concepts which are essentially required for analysis of force, that is impact of jet. So in previous lectures we have discussed uh, about the impact of jet, that is when the liquid is flowing through a pipe. In this pipe, if at the end of the pipe is a nozzle is been fitted, if the nozzle is been fitted, so what do you mean by nozzle? A nozzle is a tube of reducing cross section, like this. A nozzle is a tube of reducing cross section. So when the liquid is coming out of the nozzle, which is fitted at the end of the pipe, this nozzle has been fitted just to increase the kinetic energy of the fluid. Then when this fluid comes out of the nozzle, which will be in the form of circular or non-circular rod, which is called as jet of water. And if anything come across the jet, if you place or anything comes in the path of the jet, then the jet will exert a force on the plate, or it is called as also vane, and that force is being called as hydrodynamic force. This force is called as hydrodynamic force, and which causes the change in momentum of the liquid or fluid, the change in momentum of the liquid or the fluid, and it is also known as a impressed force, or it is also called as a impact of jet. So this impressed force or the hydrodynamic force, which is been using for the running of hydraulic turbines. So running of the turbines, when this hydrodynamic force exerts on the blade or the vanes, this vane will move forward, then the next blade will come and stand before the jet, then that also take the force, then that also moves in the forward direction, then again the next blade will come and stand before the jet, and this will continue. So these all blades will receive the hydrodynamic force, hence the rotation of impeller. Then the impeller is coupled with the shaft, then the shaft is coupled with the generator, hence the production of electricity. Okay, so this is the concept of impact of jet, and the analysis of this force, this hydrodynamic force, is being analyzed by using the impulse momentum principle. So these things we have discussed in previous lectures. So again I'll repeat, the force exerted by the liquid jet on the plate is known as impact of jet. So here we will be using impulse momentum principle. Okay, so we'll discuss about how the impulse momentum principle will be using to calculate the force exerted by the jet. So before that, some fundamental concept. So we'll discuss some fundamental concept. Okay, so here the first thing will define, so what do you mean by momentum? So momentum means any moving object can have a momentum. Can say any moving objects can have a momentum. Then how will you define the momentum? The capacity of a moving body, the capacity of a moving body to impart capacity of a moving body to impart a motion to other bodies is called momentum. Okay. This is a definition for momentum. So, or any moving objects can have a momentum. That is, the capacity of a moving body to impart a motion to other bodies is called as a momentum. Then how will you write the mathematical equation? That is, momentum can be written as, it is a product of mass into velocity. The product of mass into velocity. So which can be written as mass into velocity. And what is the unit of this mass momentum? The mass is measured in kg and this is meter per second. This is the unit of momentum. Then another term is impulsive force. Impulsive force and impulse of a force. This is very, very important. Impulsive force and impulse of a force. A force acting over a short interval of time on a body, a force acting over a short interval of time on a body is called impulsive force. You can give an example. What example you can give? A kick given to a football. So in this case, you will be giving a force when you are kicking the football, which will be, that force will be acting in a very short interval of time. That is called a impulsive force. Then impulse of a force means what? So these things you have to directly link to the impact of jet. Then impulse of a force means, impulse of a force is a given is given by, it is a product of, that is impulse of force is a product of force and time interval. Is a product of force and time interval. So what is the unit of impulse of a force? So this is a Newton, then second. This is the unit. That is impulse of a force. So impulsive force means a force acting over a short interval of time on a body is called as impulsive force. Here also this jet, so this is acting in a very short interval of time on a plate. Okay, this is called impulsive force, and this impulsive force is being analyzed by using a impulse momentum principle. Okay, so when any moving object uh, applies a force on any other body which impart a motion to other bodies, that is we defined here. So the capacity of a moving body to impart a motion to other bodies is called as a momentum, and this momentum is acting in a very short interval of time. So that is called impulsive momentum or impulsive force. And this impulsive momentum, so impulse momentum principle, next is this impulse momentum principle from Newton's second law. What is Newton's second law? That is F equal to m into A. F equal to m into A. Then we can write F equal to mass is fixed constant. The variation is what? Acceleration. That is dv by, this can be written as dv by dt. Then take this dt this time, this side, F into dt is equal to m into dv. Then further F into dt then can be written as d into m into v. Then this is called as impulse of a force. This is called as impulse of a force. So means a force which acts on a body over a short interval of time. A force which acts on a body over a short interval of time is known as impulse of a force. This is called impulsive force. F into T, that is here defined. Here impulse of a force. Force into time interval is called impulse of a force. So here we have got F into T equal to D into mv. Okay. Then further, if I write F equal to, so m you can take it out, m into dv, and this divided by t, but this can be written m, and this is change in velocity, m into, we can write final velocity minus initial velocity divided by time. Then this can be written as m, so density, you know, density equal to mass by volume, then density into volume equal to mass. So I want mass by time, you can divide this side also time. Then what do you get? Rho into q, mass per time. So I can write here rho into q. So you can write v final velocity, then v initial velocity. So this can be used. Hence in this one, so impulse, you can write impulse, you can write from that one m into, it is v minus u divided by time. Okay, from this also same. So m into v minus u, then here you get so I can write f into t mv minus mu. So what it gives? Initial momentum final momentum minus initial momentum. So impulse is nothing but final momentum minus initial momentum. This F into T is nothing but impulse. Okay, or else this also equation, this is also right. So F equal to rho into Q, mass per second, that is density equal to mass by volume, then density, then take volume this side, density into volume divided by time, then volume by time is nothing but Q, rho into Q equal to mass by time, that is final velocity minus initial velocity. Or else you can write impulse equal to final momentum minus initial momentum. Thus impulse of a force is given by change in momentum caused by force on the body. Thus impulse of a force is given by change in momentum caused by the force on the body. Next, then F into T, that is mass into final velocity minus mass into initial velocity, which can be written as Vx minus Ux. So if you are calculating force in x direction, you can write Vx. If you are calculating force in y direction, mass into Vy minus Uy. Okay, so this is impulse momentum equation. So how you can define this impulse momentum principle? So impulse momentum principle can be written, it states that the rate of change of momentum of the body in any direction is equal to the resultant force acting on the body. Resultant force acting on the body in that direction. So this is the impulse momentum principle. The rate of change of momentum of the body in any direction is equal to the resultant force acting on the body in that direction. Okay, so this can be written. Okay, so you can write this or this. So if you take F equal to mass upon time Vx minus Ux. So that is the rate of change of momentum of the body, this one. The rate of change of momentum of the body is equal to the resultant force acting on the body in that direction. Okay, so this concept will be using in calculation of impact of jet force or hydrodynamic force. Okay, so this is called impulse momentum principle. I hope you understood this one. So that is impulse momentum principle, and so this concept can also be used in calculation of or in determination of force on bends due to change in the flow direction. And even this concept is been using just to calculate the uh, losses in hydraulic jump, or you can call it a sequent depths. So there this concept will be using. So this is very important concept for this chapter, impulse momentum principle. Okay, so further you know some of the definition, that is a rate of flow or discharge. So again, the quantity of fluid flowing across a section in unit time is called as a rate of flow, and also this unit is meter cube per second. The quantity of fluid flowing across a section in a unit time is called as rate of flow, and this rate of flow also written in terms of volume rate or volume flow rate, that is Q. So how we can define this one? It is the volume of fluid flowing across the section in unit time. It is the volume of fluid flowing across the section in unit time is called as volume flow rate. Its unit also meter cube per second, or it can be measured in cumex. Then, as you know, 1000 liter equal to 1 meter cube per second. Then it can be written as Q equal to A into V. So this is volume flow rate, where A is the area of section and V is the velocity of flow. This, you know, this is one famous equation which can be used to calculate the discharge across the section. Second parameters, that is mass flow rate. Mass flow rate, that is it is the mass of fluid flowing across the section in unit time, mass per second. Mass of liquid flowing across the section in unit time, mass per second. This is called as a mass flux also. This is rho Q or rho into A into V. This is mass flow rate. Okay, this unit is kg per second, mass flow rate. And one more is third, weight flow rate. So how it can be defined? This is weight per second, that is weight of fluid flowing across a section per unit time. So this is Newton per second. So weight of fluid flowing across the section per unit time is called as mass flow rate. The unit is Newton per second. So these are the some basic things which we will be using in impact of jet chapter. So that is the rate of flow or the discharge can be written in terms of volume flow rate, that is Q equal to A into V, and this is measured in terms of meter cube per second, or sometimes the mass, it can be taken as a mass flow rate, that is mass per second, that is kg per second its unit, or sometimes in problems it can be taken as a weight per second, that is weight flow rate. Weight of fluid flowing across the section per unit time is called as weight flow rate. Okay, and in this chapter this very important thing is impulse momentum principle. Once again I'll repeat, the rate of change of momentum of the body in any direction is equal to the resultant force acting on the body in that direction. In whichever direction you apply a force, in that direction the momentum of the body get changes. If you're applying in x direction, the momentum of the body get changes in x direction. If you apply in a y direction, the momentum of the body get changes in y direction. That is the impulse momentum principle. So here impulse means a force which is acting in a very short interval of time. That is called impulse. That is impulsive force. The momentum is the change in the body. It is momentum. So that is here written momentum. So any moving objects can have a momentum. The capacity of a moving body to impart a motion to other bodies is called as a momentum. So here a jet is imparting a force on this plate. Okay, then it makes this plate to move also. Okay, so this concept, that is impulse momentum concept, will be using here. So please go through once again and try to understand this principle. So in next lectures, so we'll taking some of the cases and we'll derive some of the equations, how this impulse momentum equation can be used to analyze the force of hydrodynamic nature, that is impact of jet. Thank you.